Now let us see how half-life and first-order kinetics related. So what is half-life? Half-life is the time required for the concentration of a reactant to decrease to half of its initial value. For example, radioactive decay, it is first-order kinetics. So if you start with a sample, and suppose this is the example with some dots here, so we can see that that's the initial concentration. So if you count, you can see that there are 16 dots. And how much time it is taking for that sample to reduce to 8 dots. Okay, so half of its original value. So that is called half-life. So you can see that the concentration here on the y-axis is marked as initial concentration divided by 2. So from that 8, it can change to 4 in another half-life, and it can change to 2 in another half-life. Okay, so for the first order kinetics, the half-life, that is, it is changing from 16 to 8, 8 to 4, and 4 to 2, that half-life will be same. It's going to be constant. So that is for the first order reaction, first order kinetics. So the first order kinetics, we can use that formula, that is log concentration A at time t equal negative kT plus log concentration A0. We can use this formula to derive the half-life formula just by putting a half of the original concentration. Original concentration is A0, so half of that, and then just rearrange, and then we can see that log 0.5 equal negative k half-life, t half. So if you put this one in the calculator, we can see that is negative 0.693 equal negative k t half, and then we will get t half equals 0.693 divided by k. So in this case, you can see that it is independent of the initial concentration. Let's see an example problem here. The decomposition of SO2Cl and Cl2 is a first order reaction with a K equal 2.2 times 10 to the power negative 5 S inverse at 320 degrees Celsius. Determine the half-life of this reaction. So what we will do, we will use the formula T half. It is already said that it is first order reaction, so we know we have to use T half equals 0.693 divided by K. So since I have K given, I can simply substitute 0.693 divided by 2.2 times 10 to the power negative 5. That will equal 0.315 times 10 to the power 5. That I can write in scientific notation, 3.15 times 10 to the power 4. Unit will be seconds. Let's see one more question. The decomposition of N2O5 dissolved in CCl4 is a first order reaction. The chemical change is 2N2O5 gives 4NO2 plus O2. At 45 degrees Celsius, the reaction was begun with an initial N2O5 concentration of 1 moles per liter. After 3 hours, the N2O5 concentration had decreased to 1.21 times 10 to the power negative 3. What is the half-life of N2O5 expressed in minutes at 45? So this is important. And so what are the things we have here is concentration A0, that equal 1 moles per liter, and time is given as 3 hours. Since they need the answer in minutes, 3 hours should be converted into minutes, so that will be 180 minutes. And then concentration after certain time is, that is after 3 hours, it is given 1.21 times 10 to the power negative 3 moles per liter, and we have to find T half. So here we don't have K value, so we cannot use the formula T half equals 0.693 divided by K. So what we have to do, we have to find K first, and it is given as its first order reaction, so we have to use log concentration A at certain time t equal negative Kt plus log concentration A0. And then we can substitute the values given. Log 1.21 times 10 to the power negative 3, that equals negative k, and time should be in minutes, 180, plus log, what is the initial concentration is log 1, correct? Yes. And then log 1.21 times 10 to the power negative 3, just plug it in the calculator for log 1, that is 0, right? So then log 1.21 times 10 to the power negative 3 divided by 180 will give negative k. So that is equal, we will have negative 6.7 divided by 180, that equals 0.037. That is our k value. After getting k value, we can substitute here. So t half equal 0.693 divided by 0.037. That will equal 18.6 minutes.